All right. Regardless of the length of the question, the first thing you have to figure out is what does the author want from you? Okay. And so for this author, they're asking you for drops per minute or mLs per hour. Okay. And those can be calculated a couple of different ways. For this question, let's start with the drops per minute.
Um,
I'm going to go to the whiteboard. So, what I want you to take out of this question right now is if you're doing drops per minute, what's your formula? Okay.
oh,
So, it's very important that you know what your formula is. That's going to tell you how to set the problem up. So, for drops per minute, what you have to remember is my formula is total volume over total time in minutes times my drop factor. And it's always a whole number unless the question should tell you to do something different. I won't ever tell you to do something different with it on the tests that I create. However, some of the new formats, like for Kaplan and stuff like that, are doing a little bit different things with these questions. And I think really what they're trying to gauge is the nurse actually reading what the question's asking. But for the purposes of the exams you'll be taking that we'll be giving you for math, the expectation is that's the formula. So total volume over total time in minutes times your drop factor, always a whole number. That is your total formula there. Okay. So when you go to the question, if that's your formula, then you have to find those components. All right. So total volume is going to be anything that is in mLs or that can be converted to mLs, because sometimes your volume comes in liters. All right. Most of the time, you won't see like kiloliters and deciliters. You definitely won't see those on our exams. You could see it on an exam that I don't have on an exam question I don't have control of, but I don't expect it. I would expect that your volume would either be in milliliters or liters, and if it's in liters, you have to convert it to milliliters. Okay, so look in the question and find what has milliliters behind it, and that's a very important part of the question, because sometimes what you might see here is the client has Rosefin ordered 50 milligrams in 250 mLs. And what mistake the nurse will make is she will take the component that has milligrams behind it. And milligrams is the strength, it's not a volume. For this question, it requires that you have the total volume. So now, what is the total volume in this question? Anything with mLs behind it. And you really only have one thing, right?
yes.
And that's the 250. So that component is going to go on the top. I'm going to go to the whiteboard and do this. That component is going to be on the top. So you have 250 mLs. That's your total volume. All right. And then you have to have your time in minutes. So right now you have 2 hours and 45 minutes. Your 45 minutes is already in minutes for you. So you have to take your 2 hours. All right. And you're going to convert that into minutes and you're going to add that to the 45. We're going to do all that on the whiteboard. And then you need your drop factor because it's times the drop factor, and your drop factor is 60 GTT per ml. So those are the components that you need out of this question in order to answer this. Okay. And then it's also asking you for mLs per hour. So this is asking you for drops per minute and mLs per hour. All right, we're going to go to the whiteboard now. All right, let me know when you can see my whiteboard.
You can see it.
Okay. All right, so again, our formula is total volume over total time in minutes times our drop factor, and always a whole number. All right, our volume was 250, we said. And our tubing is 60 GTT per ml. And we're looking for drops per minute and mLs per hour. All right. So we're going to do the drops per minute first. All right. So we have 250. Now our time was 2 hours and 45 minutes. So we're going to convert this, right, by multiplying it by 60. So that gives us 120 minutes. So we're going to add that 120 to our 145, and that gives us 165 minutes. Okay, so now you're going to do the math. Take the 250 divided by the 165, right? And multiply that by the 60.
That gives us 90.90, 90, rounded to 91.
Okay, is that what everybody else got? 90.90. So what whole number would that convert to?
91.
Okay, now if you're having a problem converting there, this is what dictates that whole number. So if this is greater than 5, then it's going to go to 91. If this were 90.4, then it would stay at 90. Okay, so you get 91 drops per minute. Okay, now the beauty about this is if you did it this way, you already converted your entire minutes into, your entire time into minutes here. So there's a couple things a couple ways you could do this. Okay. You're doing mLs per hour. So for mLs per hour, what is the formula? So that is your total volume over your time in hours, right? And you know that your total volume is 250, but your time in hours is mixed. So you could do one of two things. You can either divide it by the 165 and multiply the whole thing times 60. Okay. Or you know that if you're take the 45 and divide it by 60, you're going to get 0.75 because 45 minutes is 3/4 of an hour, which is equal to 0.75. So you could use 250 divided by 2.75. In this case, because your drop factor is 60, you have a little bit of an advantage. The drop factor is not always 60. But because the drop factor is 60, this question is going to give you basically the same answer for drops per minute as it will for milliliters per hour. And that's because you have a drop factor of 60. Okay. Normally, you don't have a drop factor of 60. Your math is not going to come out like this. But for this, you should still end up with 90.9. And go ahead and do the math both ways. 250 divided by 165 times 60, and then do 250 divided by 2.75. You should get the same exact answer. Did you?
I got the same answer for the 250 divided by the, I mean, two 250. Wait a minute. Oh no. Okay. 250.
So for this question, you're going to have 91 because you converted this to 91, right? And milliliters per hour, depending on how we ask you to document it. Typically, I'll ask you to round this to a whole number, but not always. Sometimes I might ask you to round it to the nearest tenth. All right. But in this case, let's see. I think the author wanted us to round it to the nearest whole number. So let's I gotta figure out where's my trying to go back to the question. Okay. Zoom's so new, it's got me doing weird things now. Okay, now we're back at the question, okay? And then question says round both answers to the nearest whole number. All right. Now, was everybody able to get to 91 for both answers?
No, I only got 91 for the minutes.
Okay. Everybody else isn't talking, so I don't know how you're doing if you don't talk.
I got 91 for both.
Okay.
I got 91.
All right. So again, for mLs per hour, your formula is total volume over your time in hours. In this question, it gave you your time mixed. So your time is 2 hours and 45 minutes. So you either have to use the conversion after you do the division and convert all your time into minutes, or you have to put all your time into hours. If you use 250 divided by 2.75, then you're using hours here because 2 hours and 45 minutes converts to 2.75. How does it do that? How do you convert that 45 minutes into an hourly rate?
You
You
divide it by
divide by
60.
60.
Right. And when you divide it by 60, you should get 0.75, right?
Yes.
And then
Yes.
so now you have 2 hours, 0.75. You could have also taken the 2 hours because we already did this part, right? We did this part where we did the 2 hours and we got 165 minutes because we took 2 hours, multiplied it times 60, which gave us 120 minutes. We added that to the 45, and that gave us 165 minutes, correct?
Yes.
This is good to know when they give you your time just in minutes, but you need it in hours. So if they give you your time in minutes, but you need it in hours, you can just use the minutes. So you see, your total volume was still 250. Your total time was 165 minutes. If you did that math, 250 divided by 65, and you multiplied it times 60, which would convert those minutes into an hourly rate, then you're still going to get 90.9. And then if you round it up, it comes out to 91. Are we good?
Yes.
Okay.
Yes.
All right. So now we're back on the question. So we got 91 and 91. Okay. Now it says the infusion time was set on 1500. All right. So that's 3 p.m. because that's military time, right? That's a 24-hour clock.
Yes.
Okay. If you're not sure if it's past 1 p.m., because 12 noon on a military or a 24-hour clock is going to look like 12.00. That's your 12 noon mark. Anything past 12 noon, you just add 12 to or subtract 12 from. That gives you your 24-hour number. All right, so our infusion was set here at 1500, right? And the bag is running at 91 mLs per hour. All right. We have 250 mLs. So now you have to take your 250 mLs and divide it by your rate per hour. So 250 divided by your 91, because that's what we just calculated as the rate per hour, right?
Yes. 250. 2.46.
That gives you 2.74 hours that this infusion is going to run. Okay. So I would round that to 2.7 hours it's going to run. Your
T,
0.7, if you take your 0.7, because that's 0.7 of an hour. Okay. Now, a couple places might do this differently. Some people might take the whole 0.747 times 60 because that's a fraction of an hour. So you have to multiply that times 60 to determine exactly what your minutes and seconds are there. Everybody with me on that? So if we added 2 hours to 1500, that would give us 1700, right?
yes.
All right. Now you still have the 0.742 blah blah blah. Okay. So let's see, if I take the 0.7 times 60, that gives me 42 minutes. So in my math, if I was doing this, I would say it's going to end at 1542. Okay, but let's see if I take the whole amount, the 0.74, see if it makes a difference in the answer. So 250 divided by 91. All right, I get 44 minutes, almost 45 minutes that way. So I'm going to put in the 1542. Let's see if they give us an answer of 1545. Let's see how they rounded it. So we got they gave us the 1745. So they took the whole end of the number. All right. So if you guys aren't with me, let me just show you here on the
Yes,
whiteboard.
thank you.
Please.
Um,
Okay, so we figured out that the pump was running at 91 mLs per hour. We had a total volume of 250. So we needed to take the 250 and divide that by the 91. All right, and that should have gave you, hold on a second, 2.7472527473. Okay, that was the answer you got there. So this is also, what's my screen doing here? This also is representative of hours, but it's a fraction of an hour because it's behind the decimal. Okay, so in order to convert this into minutes, because that's what you have to do, convert it into minute and seconds. You have your 2 hours here, but what is this time? So you could easily take your 15 and add your 2 hours, right? And that gave you 1700 hours. So you knew that it was going to stop at 1700 hours, but you didn't know what this amount was equal to. So in order to All right, the way they did it. Now, what we could have tried to do is maybe round this. Use the 7 and round this. So let's try it. Take 0.75 and multiply that times 60. Then you get 45 minutes. All right, so then it would have been 2 hours and 45 minutes, okay?
Got it.
This is 1500, so that would have made it 1745. All right, so here's going to be your thing. If your number here, if your fraction of your hour here ends up to be 1,000th place, to round it here. And that should give you the right answer without using that great big number. I took the whole number and multiplied it times 60. I still got the same answer, okay? Everybody with me on that one?
Yes.
Yes.
That was a little tricky, but you can do these. It's not hard math. It's just knowing the steps. What do I need to do to convert to get to what they want me to know? Okay, you guys can see the questions again?
No, your screen is
It's,
okay, we see it now.
Somebody's cutting in and out.
No.
Is that me?
yes, we can hear you.
Yeah.
Can you guys hear me? Okay, can you see the next question?
Yes.
Yes.
Okay, so this one's asking us for two things. This one's asking us for mLs per hour or drops per minute. Okay, so not quite as complicated as the last one. You don't have to do a time here. So what is your, so again, here is what you want to read here, okay? To safely administer, the nurse would set the IV pump at what milliliters per hour and at how many drops per minute. That tells you how they want you to set the formula up. So you could start with mLs per hour here. You see that you have 250 mLs for your total volume, right?
Yes.
And then it's going over 2 hours and 30 minutes. Now you're doing mLs per hour. So what's the issue?
The minutes.
Okay. So how do you want to do this? Do you what? And this is what you have to decide. There's no right or wrong way to do this, but let's just write down our 250 and let's write down our 2 hours and 30 minutes so that we have both of them when we go to the whiteboard. So here, the first thing your author wants is mLs per hour. You have the mLs, no problem. That's your 250. But your time is mixed, okay? It says 2 hours, 30 minutes. Now, how do you want to convert, okay? However you do it, you should be the same thing the whole time, okay? For me, whenever I have minutes in an ml per hour question, I'm always going to do it this way because it's consistency. I know 2 hours is 120 minutes, so 120 plus 30 is 150 minutes. My 250 ml divided by that. That gives me 1.66. And I'm going to multiply that times 60. And that's going to convert these minutes into an hour. Okay, so this is 1.66. You're going to use that whole number, by the way. When you divided it, you should have got 1.6666666667, right?
And then you keep that.
Yeah. Okay.
Keep that whole number, and you should end up with 100 milliliters per hour. Is that what you got?
Yeah, 99.9. Yes.
Okay, you could have took 250 and divided it by 2.5 because you should know 2 hours and 30 minutes is 2.5. If that's the way you like to do it, if that's how your brain works, then do it that way. Because when you get on the test, your brain's going to be stressed. But whatever method you use, it has to be consistent. And you just have to remember to do your conversions. If you're using minutes, you have to convert it to hours. Here, it's already converted to hours. So if you do the math that way, you're still going to get 100, right?
Yeah.
Yes.
I show both ways, not to confuse you, but because what will you remember on the test? And the key is consistency. Practice, practice, practice. Just that share. Oh, let's just stay here for a minute. So we had a drop factor of 10. All right, for this problem. So now we can go back to our original. Here we're going to calculate our drops per minute. So we had 250 mLs because we needed our total volume still. Our total time in minutes was 2 hours plus 30 minutes. And we said that was a total of 150 minutes, correct?
Yes.
And then our drop factor was 10. Okay, now what's the final key? Because this was our answer, right? This is what you should have got.
Yes.
So now how many drops per minute is it?
17.
17. Good. Okay, everybody go with that one.
Yeah.
So we got 100 mLs per hour. We got a drop factor of 17.
I got a question. The
Yes.
250, like the other way that you said that we could do it, we could change the 30 minutes to hour and add it to the 2, it would give you 2.5. So I did 250 times 10 divided by 2.5 and I getting 1,000. I don't know.
Because on this problem, your minutes have to remain minutes. You can't convert them into hours.
Oh, okay. All right, thank you.
Because why? Look at, so this is what's important. If you look at, let's go to the question for 1 second, then we're going to
Okay.
come back to the whiteboard for 1 second. All right. Look at the question. You see how the answer says drops per minute
Yes.
versus the other one that says mLs per hour. So because you're ending in minutes, your minutes have to stay in minutes. You cannot convert to hours for that question because your answer has to be in minutes. For the
Okay.
other one, you're converting your minutes to hours because your answer has to be in hours.
Okay. All right, got it. Thank you.
Okay, see your green lights. Now, there's the method that we did. We did basically the formula method for both of these, okay? But you see, they show you, how they do it there. Now, this is under nurseslabs.com. This is a free program. So if you go to nurseslabs.com to dosage calculations and you put in drip factors, you'll see, or flow rate, you'll see a bunch of practice questions there. Okay, and it'll go through all the steps with you at the bottom, just in case you made an error somewhere. All right, now let's look at this one. Okay, this is a little more complicated, right? What you don't have here is you don't have anything in milliliters, but you have something that can be converted to milliliters. Okay, you don't have anything in minutes, but you have something that can be converted to minutes. So if you look at your answers at the bottom, on the left, you have to calculate milliliters per hour. On the right, drops per minute. All right. So what are you going to need out of this problem? You need your total volume. And right now, your total volume is 1¼ liters, right? It doesn't matter what it is. So 1¼ how would you write that?
Mhm.
How would you write 1/4 in a decimal?
0.25.
Right. So 1.25 liters. So you're going to put 1.25 L, and then your 18 hours, which we know has to be converted eventually to minutes. Okay. And you have a tubing factor of 20. And we're going to calculate our mLs per hour and our drops per minute. So let's go to the whiteboard. All right, so if you wrote your problem as 1.25 liters, and you know that you need a total volume, so you're going to convert that to milliliters. So when you're going from left to right, and you're going from liters to milliliters, which is left to right, you're going to act like a rabbit and multiply. Okay, so we're going to multiply this times 1,000, and that's going to tell us how many liters that we have.
12.
I mean, milliliters, I'm sorry.
Should be
So you
1250.
should have got 1,250 milliliters, right?
Yes.
18 hours, okay? So for the milliliters to the hour question, we can use the 18, right? Have 18 hours. So now we can just do the math there. And that gave us 69.4. Is that what you got?
Yes.
Okay, and likely they're going to tell you to round that to a whole number. So what would that whole number be?
69.
69.
69. So that's your milliliters per hour, okay? Now for the next question, they want drops per minute. Okay, so here we have GTT per minute. And we know that we have 1250, our mLs didn't change, but our time is in hours. So we're going to need to convert that. So we're going to take our 18 and do what with it?
Multiply it by 60.
Multiply times 60. So 18 times 60 gives us
1080.
1080. Okay. And then we take our 1250, divide that by the 1080. And then that should have gave you 1.157, blah, blah, blah.
Yes.
We're going to multiply that whole number times our drop factor, which I said was 10, right?
Yes.
Okay. And that should have gave you 11.57, blah, blah, blah. So how many drops per minute would that calculate to?
12.
12.
12. All right, so we got 69 mLs per hour and 69 drops per minute. Let's see if we're correct. Oh, our drop factor was 20. Let's go back, because that second answer is going to be wrong. So let's go back and get the right drop factor and put it in there. Let's see, which one were we on? Must be this one. Okay, so you could just look at the question here and do it. So we're just going to do the 1250, right? 1250 divided by the 1080 times 20, because our drop factor was 20, not 10. Now you should have gotten what?
23.14.
23. Not 24. Why not 24?
Because the number to the right is below
It's
5.
below a 5, right? So you should have gotten 23.14.
Mhm.
And that would round to 23 even. Okay. So we have 69 mLs per hour and 23 drops per minute. And that's why you want to always go back and double check, because if you put something in wrong, then you have a chance to redeem yourself right there. All right. So we got 69 here and 23.
How you say it?
Questions?
No,
Okay. So how we doing with the drop factors and the mLs per hour?
pretty good.
Is there other questions you want to go over? Or you want to do a couple more of these?
A couple more of these.
Okay, now let's look at this one.
I have a
Again,
question.
go ahead.
Um, I I struggle with deciding when is it that I convert the hours into leave the hours. You know how when you do the time, I struggle when, like for example, if the time says 18 hours, should I convert that, or if it says 18 hours, am I supposed to leave it 18 hours? So I guess my question is, when reading the problem, what would indicate to me, should I leave it at 18 hours or should I just
Say it.
change?
Okay, so let's go to a different thing and let's look at a
Bonnie, what
couple
are
of
you
problems
eating?
that are going to help you determine that. Okay, let's start with this one first. Okay. So whenever it asks you, can you see the question number 2?
Yes, ma'am.
All right. So whenever it's asking you for a rate for the pump, it's either going to put this here, mLs per hour, or you're going to see GTT per minute. Okay.
Okay.
One of those two things. So this one says hour. Okay. So for this one, you have to use the total volume over total number of hours. And it's kind of right there in the statement for you, right? mLs divided by hours. Now, let's say that for this question, pretty simple, right? You have 500 mLs, you're putting it over 2 hours. So you know that your rate's going to be 250 an hour there, right?
Yes.
Yes.
What if it said 2 hours and 20 minutes?
Oh,
How would you do the math? Okay. So you have to convert those 20 minutes into an hourly rate. If you don't, you're going to get the wrong answer. So how would you do that? All right. So the 2 hours is easy because you already have that. But how do you convert that 20 minutes? So to convert 20 minutes into an hour, you either have to divide it by 60, which is going to give you like 0.3333 or something like that, right? 20 divided by 60,
yes.
0.33333. Okay. Now, in real life, if you just think about your clock, this is just something common sense to help you a little bit. Okay. If I
Stop,
gave
Bonnie.
you, if I said to you, it's 2 hours and 30 minutes, you know right away that's 2.5 hours, right? So that's going to convert to 2.5. So then I
Yes.
could just take my 500 and divide it by 2.5. If I said it was 2 hours and 45 minutes, you know that 45 minutes is 3/4 of an hour, and that's equal to 0.75. So those things you kind of know. But what if I said it's 48 minutes? Now you're kind of like, okay, well, how do I convert this? Because this isn't one of those standard numbers that just falls on the clock, right? So you would have to take your 48 and divide it by 60. Now, an easier way to do this, if you want to do this completely one way all the time, is to And let's just try a couple. I want to see if I can find one here. All right, let's look at this one. Now, two errors people make on this question. Okay, the first error is they use the 50 milligrams. And you can't. That's a strength. You have to use volume here because what's it asking you for? And I'm going to highlight it. It's asking you at what rate ml per hour should you set the pump to. So that means you need your mLs, and the only thing that has mLs in this question is 25. And then you need your time, but here's the problem. Your time is in minutes. Okay? So let's go to the whiteboard. Take down your 25 mLs because that's your volume. And take down your time, which is 20 minutes. And what does the answer want me to get to? It wants me to get to mLs per hour. Those are all the things that you need to know to answer this question. Okay, so we have to get to mLs per hour. Our volume is 25 mLs. Our time is 20 minutes. The easiest way to do this question, because your time is in minutes and you need to convert it into hours, is to do this math right here and multiply the whole thing times 60. Now, you should get 75 there, okay?
That's 75.
If it doesn't work for you, then you have to determine what works for you. So remember, what if I said you're doing 250 mLs over 2 hours and 30 minutes? Now your time's mixed. So you either have to convert all this to minutes, okay, divide it and multiply it by 60, or you have to convert your 30 minutes into a fraction of an hour and add it to the 2 hours. Are you with me?
Yes.
So either way, you have to figure out how am I going to convert that 30 minutes into an hourly rate. So if we did that, then it would be 250 divided by 2.5,
Yeah.
right? If you converted it that way. Otherwise, it would be 2 hours times 60 is 120. It would be 150 minutes. So you could take the 250, multiply the whole thing times 60, because now you have to convert these minutes back into an hourly rate.
Okay. Thank you.
It sounds like a lot, but it's really just steps. And it's what is the question asking me for? What do I need to convert to get to that answer? So here we got an answer of 75. Let's see if we're right. And again, they'll show you different ways of doing the math. Here's dimensional analysis. Here's ratio proportion. I like to keep it simple, stupid, because my brain can't process all that. Right? That's a lot of steps. Look at how many steps we did. 2, right? So on an exam, when you're timed, you have limited amount of time, and not everybody can do that formula method. That's what I use. So some people have to use dimensional analysis. I want you to use whatever method works for you. If this method works for you, use it. But if it doesn't, then what works for you? Let's look at another one of these. So here, this is different. Let's skip this one. You guys can do that, but that's above what you're doing right now, and I don't want to confuse you. course, it's not going to give me another simple one. Here's one. Okay. Now, which part of the question are you always going to read first? What that question is asking you right here. Okay. So now it's asking you what?
What's
What
the
is the
rate?
rate milliliters
What
per
rate?
hour?
Okay. So you know it wants you to give milliliters per hour. So what are the two things you need out of this problem? What represents the milliliters?
The
Volume,
200
200,
volume.
The 200. Good. And what represents your time in hours?
30 minutes.
But the problem is it's in minutes.
Minutes.
So
We
you
got to
have
convert.
to convert. Okay. Now I would just take the 200 here, divided by 30, multiply it by 60. That is converting. But you could do 200 divided by 0.5, which is also converting. Whatever way you do it, be consistent. If you do it both ways, you're going to get the same answer. And it should be 400. I already know that because if I gave 200 over an hour, it's going to be 200. If I give it twice as fast, it's going to be 400. Can't be anything else. But let me know what you got. I didn't even touch my calculator yet.
Yeah, 400.
Yeah, 400. We got
So, use your common sense and use what you know to get back to what you don't know or to double check yourself. And again, this isn't about how you do the math. It's what is going to stick when you get on the test. Because, when you get on the test, you're stressed. You'd be like, Miss Sue, I do the practice and I'm fine. And then I get on the test and my brain goes haywire. So you got to find a way to keep your brain in check. How can you do that? So again, starting with what's the question asking me and then writing down the components. I know it wants ml per hour. Let me write that component down. I know I need my time. My time's in minutes, but I'm going to write it down because that's the only thing in there that I can convert into an hourly format, right? And now I have the components I need. Now I just have to set it up. And this problem, it actually sets it up for you right here. I know that I need mLs divided by hours. What do we get? 400?
400.
All right, rock stars right there. Again, they'll set it up a variety of ways. It does not matter. Because at the end of the day, if you can't get to the right answer, that's what matters, right? Now look at this one. Let's skip this one because this one's
No, let's do that one. Let's do that one. We had something similar to that
okay.
On the test.
Okay. This is for L to R math.
I know, but
Okay, I'm just making sure because I know that I might have some people coming in now for health assessment.
Oh yeah, but we had something
Okay,
like this.
so if you're here for health assessment, we'll save this question for that because L to
Okay.
R doesn't need this.
Okay, thanks.
All right, L to R, what other questions? You have a couple more minutes. What other questions did you guys see on that test that you weren't sure about?
My issue was just the minutes.
Okay.
So thank you.
You're welcome. I did record this and I will put it up on YouTube and share it with you guys, okay?
Thank
Okay.
you, Miss Loesch.
Miss
Thank you
Lowe's,
so
Yes.
much.
could we do a pounds one real fast? The 2.2?
A pounds one? Yes.
Ms. Loesch,
Yes.
I'm sorry to cut you off. I thought this meeting was to start at 10:15. I just joined. I'm late.
You're not late. If you're coming on for health assessment starts at 10:15. All right. Right now we are doing L to R.
Oh, okay. I'm sorry. Thank you.
All right. Let's find a weight-based one for you, L to R. look at number 7. Can you see the screen?
Yes.
Okay. So again, this question is asking you how many mLs will you administer per dose, okay? Whenever you see one of these weight-based, this is really a desired over have question because the only thing you're ever going to give is a dose, right? Unless you like gel. All right. Here, the only difference is they didn't give you the desired dose. They want you to calculate it. All right. So let's start with how many milligrams you would actually give here. Okay. So your patient's weight is 115. And the ordered dose is 12 milligrams per kilogram. All right. Let's go to the whiteboard. And just remember with
What you
pounds to
spraying over there?
kilograms, the best thing to remember with pounds to kilograms is that your women like to be weighed in kilograms because it's smaller. So if you're going from pounds to kilograms and kilograms is smaller, that means you have to divide. So you're going to divide by 2.2. Whenever you're doing weight base, you leave everything in the calculator. Okay. So we have 115 divided by 2.2. And that gives us a weight of 52.27. And I put a line under it to represent infinity. Okay. Everybody with me? Is that what you got?
Yes.
Yes.
Okay.
Yes.
So now you're going to multiply that times the ordered dose. The ordered dose is 12 milligrams per kilogram. So we're going to multiply that whole number times 12. And that should have gave you 627.27. Okay. And that's infinity again. Now, if I said round it to the nearest tenth, this represents how many milligrams that the client's going to get. All right. So if I said round it to the nearest tenth, how many milligrams would it be?
And
Where's your nearest tenth?
Is it 627.3?
Yes, because this dictates this, right? So it would be 627.3. Now, you still should have that whole number in your calculator, do
Yes.
you? Okay, so that whole number is representative of what you're going to get. Now let's go back to the question, because now we're just going to carry this out a step further. All right, can you see the question?
no.
Not yet.
All right, let's see. Okay, how about now?
It's loading. Yes.
Okay, so we determined that we're going to give 6, and you should still have this in your calculator, 627.27, blah, blah, blah. Okay, that's our dose that we're going to give. And what we have on hand is 100 milligrams times 2 mLs, which is our vehicle. All right. So now you're going to take your 627.27, that entire number, and you're going to divide it by 100.
What?
Where do you get 100 from, Ms. Loesch?
Because you see what
Okay,
this
100
says? How
milligrams.
many milliliters will you administer per dose?
And then times it by 2.
What do you have on hand? So you just calculated your desired dose, right? And what's the formula for when you're given a dose? Desired over have, right?
Yes.
Okay. So sometimes these are just going to ask you to calculate how many milligrams you're going to give. Now, we just did that, right?
Yes.
Now it's asking you, based on that dosage that you just calculated, if you had 100 milligrams per 2 ml, how much would you give
Okay.
to give that dose?
Okay.
So now you're going to take that 627, whatever it is, and you're going to divide it by 100 because you have 100 per 2 mLs, right?
Okay. Yes.
And then you're going to multiply it by 2. And that should give you 12.54,
4.
which would round to what?
0.5.
12.5. Is it up there?
Yes.
Yes.
Okay. Then you just did the math right. You're a rock star. It's not hard. It's steps. Look at the next one. Now, the next one, first thing I want you to do is just calculate how many milligrams are you going to give this client. So what are you starting with?
Converting
The
to
weight,
pound.
right? You have to start with the weight. Put everything
154.
in the calculator and leave it in there. So you're going to go 155 divided by 2.2. And how do you know you have to divide here? Because your weight is in pounds. If your weight
Mhm.
is already in kilograms,
You can leave it alone.
you can skip that step, right?
Mm-hmm.
You're going to use what they give you in kilograms to multiply by the 2. Here you have to convert the weight first. So this should have gave you 70.45 blah, blah, blah. Okay? You're going to take that whole number and multiply it times 2 because that's the ordered dose. 2 milligrams per kilogram. And your kilograms is not 70 here, guys. This is weight-based. So it's important that we stick as close to the number as we can. So that's why we use the entire number so that we're not estimating up or down to overestimate. All right, now you should have 140.90909090, right?
Yes.
And that's how many milligrams you're going to give daily. But now on hand, you have 40 milligrams per 0.4 ml. So in order to give that 140 milligrams, you have to determine how many mLs you're going to give based on what you have on hand. So now you're going to take that 140.90, that whole number, divided by 40, and then multiply it times your 0.4. And what'd you get?
1.4.
So, Ms. Loesch, this question here shows 2 milligrams per 1 kg. Don't we consider converting for 70, like 140 kgs will be how many milligrams?
I'm sorry?
We converted 155 into kilograms, giving us 140.909090. So
No, wait a minute. You missed a step somewhere. We took 155, we divided it by 2.2. That gave us the weight.
right.
And we multiplied that times 2, which told us how many milligrams that we are giving for the total dose.
Okay.
Do you understand why we did that?
It's good because the question says for every 1 kilogram you administer 2 milligrams, right?
Correct. And we had whatever milligrams we got way back when. We had a total weight of 70.45454545. You were
Right.
to multiply that times the 2 milligrams.
Yes.
And that gave you 140.9 milligrams per dose that you're administering daily.
Right. I got it. Thank you.
Now you have to divide that by what you have on hand in order to get the desired dose.
Yes.
Okay.
So,
So
Miss
now
Loesch,
we're at that point. I'm sorry?
I was saying, so once we figure out what that desired dose is going to be by converting the weight into kilograms and then dividing that, now it's just simply a desire over half problem now?
Correct.
Wow.
But first you have to calculate the desired dose because that's based on weight. Why? Because like Lovenox, I have to give that based on the weight of the patient. That's heparin. Heparin's a weight-based drug. If I were given dobutamine or something like that, like those are really strong vasoconstrictors. So you have to give really minute amounts of that. And you have to calculate that amount first and then put that over what you have on hand. Because the doctor can't say, oh, give 396 milligrams because it's going to be different for everybody. So that's why you have to do that. Now you got to 1.4, right? Everybody was able to get to 1.4 here?
Yes.
And your answer's
Yes.
up there, right? This is
We can't see
registered.
the answers. What's the answers?
You can't see the answer?
I can't.
There's 4 answers, 4 possible choices there, right? 1.4 is one of them. You can't see that?
It's my screen. Let me fix it. I'm
Okay.
sorry.
2.2 times 2 equals
All right. So for anybody that wants to know, this is registerednurse.com. Just type in registerednurse.com weight-based dosage calculations. You can also type in weight-based dosage calculations, nurseslabs.com. They have weight-based, they have rates, all that, and it's all free. All right, L to R, that's the end of your session, L to R. I'm about to go into a health assessment.
Thank you so much, Ms. Loesch. Thank you.
you.
And this, I'm going to stop the recording when I get a chance to convert. Then I will send you guys the links. They will be on YouTube.
Thank you.
Thank you.